to have conversation with Sri. So this is unrehearsed. I don't know what kind of question he's going to ask, and if he's going to throw me under the bus, I'll accept it. Okay, so here we go, Sri. Let's get started.
Thank you. Thanks, Agus. I know you heard a lot of. It was a brief introduction to Agus. Agus is I usually introduce him as a lot of all models, both in banking and cars and whatnot. So let's kick off with how. So you have obviously we were talking about that briefly recently. 2 decades in the banking industry, a decade in automotive, and then actually papers that you published when AI did not have any. There were no jobs when you came out for when you were doing AI. Quick, maybe 5 bullet points between difference in how you would test a AI or a car versus a bank.
Sri tried to make me feel very old here. She reminded me that when I did my dissertation in the early '90s, mid-'90s, is in neural networks. So that's how old I am. So people may think I'm young, but I'm really old. But anyway, I did my PhD in machine learning, where no such job as machine learning, no job as data scientist, by the way, at that time, right? So with PhD in machine learning, I cannot find a job in machine learning. I'm not a statistician, so no statistical company or whatever looking statistician will not accept me as a statistician. So I have to find real job, and my job then becoming designing real machine instead of machine learning. So I designed car engine for Ford Motor Company, and many of you that drive 3.5 liter V6 engine. That's the engine that I designed, the last one. That was 25 years ago. And that was, today is the most reliable engine ever designed at Ford Motor Company. So that was first stage of my life. And then I went to the dark side. I went to banking. So spent 20 years in banking with Bank of America, Lloyds in UK, and then finally Wells Fargo when the inception of we have the god of model risk management here in the room, David Palmer, the godfather. So David will have conversation on the stage later, listen to his wisdom and experience. So David basically created my job. And so every bank has chief model risk. The job of chief model risk, it used to be a very high occupational hazard. The early days, because if bank fails stress test, the head of model risk will be fired. So that's a very high occupational hazard at the early day of SR 11.7. That's what David Palmer going to talk about today. But the key most important things is really this. Sri asking me about the 5 points. When we design engine, we don't just put things together. It's all by design. We're thinking carefully about the design. That influenced me greatly when I'm working in modeling. So model need to be designed, just like engine need to be designed. And they need to be tested. And they need to be tested thoroughly, and we need to know when the engine going to fail before we're going to put in production. We don't make the customer fail. We don't let product into the hand of customer, and customer have problem, we'll figure out, then we will go bankrupt because of warranty costs. So that's in the product development. The problem today with GenAI, people implemented, put GenAI in production without proper design and without proper testing, and let it fail. Let customer experience the failure. And I'm not going to name a name, in those very a lot of high profile today, and the accident, and I don't know if Patrick's all in the room. Patrick maintained database on the AI accident. And we so the thinking about no one of you will deploy software without proper testing. Nobody will deliver product without proper testing and validation. test to failure, understand when failure will happen. Nobody with the right mind will do that. But yet today, people do that with GenAI day in and day out, every day, without knowing how to validate, how to test this, and people deploy it. That is incredible to me. And this is the discipline of model risk management, by the way. Some of you that's not in financial institution. In financial institution, we have model risk management, which David Palmer is the godfather, and we'll speak about this later today. In financial institutions have been doing this since the 2011. That's SR11, SR11.7, right? I'm in the execution, the implementation starting in 2012, and so we have long history, more than 10 years executing model risk management. They have to have the discipline. People understand how and what are the potential failure of model and what will be the harm that model will create when the model fail. Harm to the institution who are using it and harm to the customer as well. And with that, the discipline of designing model, which is model development process, and then independently validate the model, to test it thoroughly, to test to fail, to understand the model weakness. It's the whole discipline that the financial institution has been practicing for decades today. And that's what really I would like to see more, Sri, how in the Gen AI world and the AI world, the complicated machinery, that people really thinking, have a design thinking, and have the discipline of managing the risk of AI.
How, so generative AI has a very large surface area, right? So models, and say a GLM, we are able to, or a GBM even, through your work on explainable deep learning, you found with Alethea and others in PyML, we brought a pretty solid pedigree of testing on validation for, I would say, predictive AI. For generative AI, what is, does Agus have a medicine?
I probably will draw from the area that we know very well and we have done it so well, predictive AI. And the predictive AI and in our battle-tested practice in model risk management, which I highly recommend for many of you that have not read SR11.7, please read it, because it's an incredible document and is battle-tested. It ran in all the banks in the US, particularly large bank, for the last 12 years. So it's really working. And in that, when we talk about testing and validation, it has 3 components. One is conceptual soundness. How sound the model is from the design point of view, and we'll talk about that a little bit. Secondly is outcome analysis. Test the outcome. And we'll talk about the component of that. And then ongoing monitoring, which is do this outcome analysis all the time, regularly. So let me talk about conceptual soundness, something that relate to and what we learn from tabular data, what we learn from predictive AI. Conceptual soundness has a 4 component that we use, that we do testing day in and day out. One is conceptual soundness start with your data. The data that are used for model development and the data that are used for model testing. Very carefully selected, very carefully constructed to build model and to test models. Soundness, quality, and suitability of the data. We don't download any data and then just use it carelessly, right? Need to be very, very careful, need to be governed data that we can and we cannot use.
So one can poison their RAG system by uploading documents that have fake news?
Absolutely, right? Oh. So understanding all of these are very important. So data start from that. Second In tabular data, in predictive AI, we have variable selection. What variable, selection of variable and what makes sense to be input. In GenAI, we don't have variable selection, but we have prompt design. Your prompt is your input, is the equivalent of the variable. So prompt is very, very important. Third is explainability. We need to understand how the input produces the output. In tabular data, we do that all the time. In predictive AI, we do that all the time through understanding through effect plot, how the input affect the output. Through visualization, through low dimension understanding, and all of those things. We can do similar thing too with this complicated machinery with GenAI, because we have input and we have output. You give prompt, you get answer. And prompt is represented in the machinery in the embedding, instead of the equivalent of it just distributed representation, high dimensional representation, let's say 1,000 dimension. The output is yet the answer, also can be represented embedding dimension. So you can do input-output attribution in a very clever way, which we are working together on this, on the how to do that, to explain high-dimensional relationship between input and output. The answer is yes, you can have explainability even for GenAI by understanding how the input and output are embedded and how the relationship between input and output. The fourth component is benchmarking. We test it with alternative model and how those compare. So 4 elements in conceptual soundness that we learn from predictive AI, from tabular data, applicable for GenAI. And then outcome analysis. The outcome analysis, it has 4 components too. One is understanding model weakness. In what situation the model will be more wrong. In tabular data, we do that. Understanding the segment of data that will be more wrong. In tabular data, in GenAI, let's say with RAG, we also can do that. What are the cluster of document chunk that you're trying to retrieve and the prompt? We're talking also about reliability. How reliable is the output of a model? And understanding in what situation the model less reliable. This dealing with outcome uncertainty. In tabular data, we do it. In GenAI, we can do it too. The third component is what we call it is model robustness. And this is notorious in GenAI. Robustness means with input change a little bit, the output should not change dramatically. Unfortunately, GenAI, many of those are not robust. With prompt change a little bit, the output can go very, very different. So testing for robustness is so important. In engine design, we test robustness a lot because your engine, your car, has to operate in very hot temperature in Death Valley, very high altitude in Colorado, very cold temperature in Bemidji, Minnesota, very hot in Miami, right? So product need to perform consistently across different conditions. Same thing in here. So we have to talk about robustness. And the fourth component is environment change, distribution drift. How the model will perform under distribution drift. That's we do in tabular data, in predictive AI. We need to do it the same way on the generative AI. We can do it. So there's 8 components of model validation. Testing, rigor has to be applied for as well to GenAI. And then, of course, the issue of fairness as well. When fairness really matter, model cannot be discriminatory against protected class. It has to have testing on that as well. So that's 9 elements of testing applicable to GenAI. Let me ask that question. For some of you that already deploy GenAI, have you done any of those tests? Even 1 or 2, let alone 9 testing. So that's where we are today in GenAI. So and this is what we're trying to solve together, right, Sri?
Yeah, no, touching on robustness a bit, can we use GenAI to start, can we use LLMs, maybe even smaller LLMs, to increase the space you can test with prompts?
Yeah. This is the challenge in terms of testing for GenAI, right? Because, well, we do testing in GenAI, we can do manual testing with human testing. With the prompt, we perturb the prompt, and all of those things, how the model will react. This is very, very time consuming and not scalable. That's why people don't do it. They skip that and say, oh, it looks good, deploy. Then all kind of accident happen, right? Like what you see happen with Google and all those things, right? Because, hey, it looks good, let's send it out. So the testing of human testing is very expensive endeavor, and it's not fun for most people. People want to build model, build application, not to test application. Testing is not fun things to do, and it's expensive things to do. Now, we can make it easier. We can use GenAI to test other GenAI. You can use GenAI to do automated testing. You set it up in a clever way to be adversarial, to be in cooperation, to test. Of course, at the end, we have to have human verification, but we can sample it. We can work to have GenAI to test it at scale, so we can test it extensively with another GenAI to test. Then you sample it for human evaluation to confirm, looking at the concordance between the machine testing and human testing, and do calibration or put a confidence interval on the machine testing.
How now Wells Fargo is, given that you have created a kind of almost incredible amount of architecture, and the bank has invested a lot in designing model validation frameworks for predictive AI. And then, of course, you now are doing more things in generative AI. Maybe you can give a color of how you've reduced the surface area, for example, because many of our customers are going to just open up their chatbots and GenAI to wider audience. How to prevent the headline in Washington Post or New York Times for our customers?
This is a very, very interesting question, because unlike predictive AI, that the input are bounded and the output are bounded. Model can misbehave, but it won't be crazy misbehave, right? Unpredictive. In GenAI, anybody can put any crazy prompt to produce any crazy output or potentially crazy output. So I commend the brevity or carelessness of people that put open chatbot out there that people can do whatever question that you ask. And a lot of accident already happened on that, right? So, including the most recent incident. The key thing is, in all of this thing, we need to bound it. We need to bound the input and we need to bound the output, because otherwise, somebody is going to shoot themselves on the foot if you have unbounded, because this can do anything, this thing. So model need to be for specific purpose and bounded. And how to bound it, and in particular why this binding it is very important, because all this Gen AI, unlike predictive AI is carefully designed with the specific data for specific purpose. Gen AI is not by design. They're just throwing, especially if using if model is not trained with specific data, but with data from internet and all those things. It's unbounded. All crazy stuff in there. And it can misbehave very easily, because all this model do are interpolation and extrapolation. It's statistical interpolation and extrapolation, no more than that. That's what the deep learning is. So it will do interpolation, extrapolation unless you bound it. it will do all kind of crazy things. Possible, or your customer can do whatever, the user can do all kind of malicious stuff. So you have to be bounded. How to bound it? Well, people do bounding by doing band-aids today, because the model is not by design to be very careful. The models as it is, so we have to put band-aids by controlling the input and controlling the output. Bound, control the prompt that can go in, and control the output. So you have all the post-processing on the output, checking the output so that it no toxicity and all of those things. People can do that. But controlling the input is probably the smart way. So not allowing anybody to ask any question. You have to dumb it down if you bound it. Meaning it will be mapped, any prompt will be mapped to very well-tested prompt. So it's not...
So if you're doing a press conference, the reporters are asked to stay within certain boundaries of asking questions.
Correct.
And the president is allowed to only say certain things and
Yes.
not things that he already knows.
So that's exactly what we do. Like what we have is you translate it into any given prompt, you do it into becoming like multi-logit problem. Okay, because this prompt, it mapped to this prompt. This prompt mapped to this prompt. So any crazy prompt, it will not be answered. It will not go into the system, so you don't get the crazy answer, right? So binding the prompt, and a lot, unfortunately, with this GenAI in the current stage, you have to control the input and control the output. Controlling the output is a lot more difficult. I would say control the input is a lot easier, a lot more practical. So you have to settle with dumbing down, meaning that this GenAI can only respond to 1,000 prompt or 2,000 prompt that is very, very well designed. So any prompt that happen, it will be mapped to this 2,000 or 5,000 prompt that are already very well tested. If you're going to deploy a chatbot that will interact directly with your customer. So you have to think about the key, and many different ways to bind it.
You're reducing the attack surface. The surface area is being reduced, and now it becomes more and more purpose-built in that sense.
Yes. Just like you tell people, don't go to, watch your language. Yes. So that's what.
Very controlled answer.
Very controlled answer.
Let me ask you, since we are at that, at the how it is working piece, everybody throws around attention is all you need, right? And of course, attention is actually a very powerful innovation. Why does attention work so well in neural networks?
Yeah, this is a very technical question actually, so I'm trying to make it really, really less technical. Attention is if you look at the math, is a very, very clever trick. If you look at neural network, and I wrote a paper on this, neural network, I'm going to use the simplest one, is the specific activation function in neural network is neuron has activation function. And the most common one is probably variation of ReLU, called ReLU, or some variation of that. ReLU is basically if the value of the output is positive, it'll get propagated. If it's negative, it will threshold into zero. So that's how it get nonlinearity, because either linear or zero. Combination of that, combination of linear will be still linear. So what neural network has is basically with ReLU is locally linear model, just a lot of them. 1,000 of them and million of them, and can be trillion of them. So locally linear. And locally linear, some of you that have a background in statistics, it doesn't have interaction term. If I have variable x1 and variable x2, and if you think about regression, locally linear regression is coefficient regression. The coefficient in regression is constant, right? Locally linear, but constant. And it's finite, it's constant. Now, what happened in attention is very, very clever trick.
By the way, locally linear, one of the most profound question I received on locally linear was my daughter. She said, if the Earth is spherical, how come when we drive a car, it appears like I'm driving on a straight line?
Yes.
Right? So it's locally linear, but the global structure could be very
It's
different.
non-linear,
Yes.
exactly. So you see the regression coefficient is constant. What attention does is, no, I'm not going to make it constant. I'm going to make this coefficient vary for each sample. For every point you enter is a different coefficient. So that's what attention is, because it has coefficient as a function of variable itself. Okay? So it's very, very clever. The model becoming very, very flexible. If you give this parameter, you can fit elephant, you can fit anything, because every point has its own coefficient. So that's what the model in attention mechanism is. Very clever trick to make the regression coefficient vary. So then you can fit anything. So that's what this one is, because we can do that now. You train it to understand the relationship between that one variable to the other. So it's very, very clever trick. Very clever statistical trick, I would say, mathematical trick that works so well in high-dimensional data, which is what language is. Because in language model, basically every word is a variable. So you're dealing with very large variable. Is the number of tokens, basically. So how do you compress it, reduce it into small, and still understand the relationship across? That's what attention.
I think the interaction variables are showing up through attention mechanism, which is
Correct.
a pretty
Correct.
powerful way of thinking about it.
Yes, putting interaction, because local linear has no interaction, now you have interaction. Interact with other variable because it's a function of other variable. So it's a very, very clever trick.
Well, Arno and team are going to try attention-free LLM one of these days, so we'll see how that performs. It has a very long context.
Yes.
But we'll see if long context beats attention. We started with a topic of how you, same with me, I remember being in a room full of technical professionals in the Y2K era, thinking, why is Sri working on AI when so much, it's not practical. So in the mid-90s, it was impractical to have an AI as you in a space you can work in. Now it's all AI, and every technologist we know, universities are producing incredible amount of AI folks. Some people are saying you don't need to code anymore. Some people are saying you don't need to learn statistics or math anymore. What should somebody graduating or parents who go back home think about putting their children to? Right? What should they learn now if you have to be relevant maybe?
That is an interesting question. Let me say this using the analogy. When I design engine, we use engineering techniques, mechanical engineering and electrical engineering and thermodynamics, statics and dynamics and all of those things, right? So we use engineering tool. Behind it is physics. But if I use physics to design engine, I will never come up with product. I have to engineer it. So the engineering are important to study. So a lot of AI today, the successful one is because of the engineering approach. But behind engineering approach is the math. Of course, you use math, you will not come up with the large language model. But that's the foundation. From the math, then you do a lot of engineering. So the math will stay there. The engineering approach, the techniques, the trick, it will change. So somebody that want to come to this have to study the fundamental, because the fundamental never change. The physics don't change. How you do it, engineering-wise, will change. So that's something. That's why in engineering school they still teach physics too, in the basics on physics. So the same thing in GenAI. The fundamental, the AI, the fundamental of math, linear algebra, discrete mathematics, the probability, and all of those things has to be there. That will be long-lasting. The package, PyTorch, or things will change. So if you think about not studying that, but studying the things, then you have to catch up with technology all the time to learn the trick. So I think that's how I view it. Maybe I'm old, I'm dinosaur, because my knowledge, but surprisingly, This is surprisingly. I remember in 97 in NIPS conference, which is today's called NeurIPS, 97. I spoke about autoencoder, and the speaker before me was Jeff Hinton. Today we still the same autoencoder. That was 97 presentation in NIPS autoencoder. Today we still talk about autoencoder. The math doesn't change. Of course, the engineering trick to deal with very, very large machinery that we have today changed.
What about, large organizations? You brought change in organizations, regulated banking organizations are harder to change. Cultural transformation, data and AI are much, the agile organizations which are embracing change, are embracing diversity in opinion and likely to succeed. What human things would one need to have as they go into bringing AI into?
Yeah, I think this is I'm speaking from experience from big company and regulated entity that tend to be very conservative in technology. So we have people that want to rush very fast, want to embrace things and do things very fast, and then we have people that is very scared about this thing too, very conservative. But I think the knowledge, having the knowledge is very, very important so that you can move at the right speed and with confidence. So somewhere in between, sometimes difficult to change because of lack of expertise, lack of knowledge, so people are not comfortable about. So having people that will be able to communicate, to explain things in a very simple way, I sometimes that's in my case that's my job, to do management entertainment, I call it, because I have to explain something that complicated in an easy way to the senior leader. So the ability, and sometimes I said, and I look at it. I have a term here to be a geek who can speak. And because you have the competent people, they understand the methodology, but also are able to articulate and explain, influence people in terms of change.
No, I think
We're out of time, Sri.
you're just on the verge of the final probably question. People who are now just getting into AI, there's a lot of audience, not just here, globally, that are finished 10, 20 years of career, and then now suddenly faced with a lot of obsolete things that they cannot or will have to change. What are the fastest ways they can pick up AI so that they can go running into charging with ChatGPT into their businesses?
This tool will, of course, impact a lot of things that we do. We are at a very early stage to use this one as a productivity tool. And understanding how we can use and how can we live with GenAI. And I said we are at the early stage of GenAI because the GenAI that we use today is only as a productivity tool. It doesn't bring new insight. Predictive AI, predictive tool bring new insight. Something that we don't know before, now we know it, revealing pattern, and all of those things. GenAI today is not in that yet. It's a productivity tool, as it's helping me to write sentence, or sometimes it helps to do a mindless entertainment too. But it's something that useful for that, and we need to embrace it. We know how to use it right. We know what this thing can go wrong, and how to use it appropriately. So I think it's a point of no return today. In terms of AI, we have to embrace it. We have to learn it, live with this tool, and understand how to use this tool appropriately.
Well, I think that's all the time we have for today. But you're been a phenomenal GenAI proponent, as well as building safety for GenAI proponent. And with H2O over the last 3 years, last three GenAI Worlds, I would say. It looks like 3 years, but only 3 months. We've been continuously innovating and co-creating and learning from the audiences globally. So I think.
If I may say one last thing, Sri, on this. We are in the era that we're going to drive very fast car. If we're driving very fast car, there are a few things that need to be done. Your car needs to be very well engineered. Have a good brake so that you can be fast and you don't get killed. Right? So that's very important to have all the safety and all of those things when using very sophisticated and fast car. And the driver need to be very well trained. The driver of Formula One is not the driver of Ford Explorer. So the driver need to be very, 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 very well trained so that we can use it appropriately. All the safety and all of those things need to be done appropriately. So that's, if I may say, this is something that I'm very passionate about.
Good brake system to drive very fast.
Yes, have a very good brake system, good navigation system, so that you can drive very fast and will not get killed or kill somebody.
No, with that comment, thank you so much.
All right, thank you.
Thank you.
Thank you so much.